Welcome to Lesson 39, Using the Distributive Property to Simplify Rational Expressions. We're going to start today with a review of what a rational expression is. So please write in the definition, which is an expression that has, or with, a variable in the denominator, and we're going to use the distributive property today to just simplify expressions and make them a little bit easier to deal with. So, looking at the first example, when we're dealing with rational expressions which have a numerator and a denominator, you can either distribute both the numerator and the denominator to the first term in parentheses, or you can distribute the numerator to all the numerators in parentheses, and then the denominator to all the denominators. So we'll start with the first way first, and we'll do each one so you can see. So the first one, we have a times a squared, which is a cubed, and then b cubed times b would be b to the fourth. Then we have a plus sign here, and then we're going to distribute both to the next term. So a times 3b squared would be 3ab squared. And on the bottom we have b cubed. There are no other b's to add to that, and a z. Now looking at this example, our last step here is to see if there's anything that can be canceled. So in the first term we have a cubed over b to the fourth. So there's nothing that can be canceled there. So that's going to stay the same. A cubed over b to the fourth. Plus, in the second one, we have b's in both the numerator and the denominator. So two of these b's are going to cancel out two of the b's on the bottom and make this b to the first power, which is just b. So on the top, we're left with 3a, and on the bottom, we're left with 1b and z. So that's our final equation. The last thing we need to do is list any variables that cannot be 0. We can never have 0 in a denominator because you can't divide something into 0 groups. So therefore, b can never be 0 because that would make this first fraction here invalid, and z can also never be 0. So b and z cannot be 0, and that is part of our answer. So our answer includes all of this, the equation and what we call the excluded values. So moving on to another example, this time we'll distribute all the numerators first. So we have x squared times d times m times y, and then we have a subtraction sign here. And then we have 2. X cubed and x squared will become x to the fifth because we add the exponents, and then y. Okay, then we can distribute the denominators. So c squared times x squared times a in the first term. And this one doesn't have a denominator, so we just assume that it's over 1. So then it would be c squared times 1, which is just c squared. Okay, now we can move on to canceling things out. So looking at the first term, we have x's in the top and x's in the bottom, x squared and x squared. So those are actually going to cancel out to be 1, which just cancels them out altogether. Actually, maybe I should just use a scribble. Okay, and there are no other variables in common, so we just have dmy left on the top and c squared a left on the bottom. And in the other equation, there's nothing in common there, so that's just going to stay the same. 2x to the fifth y over c squared. And our excluded values are c cannot be 0 because it's in the denominator, a cannot be 0 because it's in the denominator, And then we always want to go back to the original equation and check to see if there are any other variables in the denominators that did not show up in our simplified version. And we have x in the original denominator, so x can also not be 0. So that's our final answer there. Okay, and then the next example. We have x squared times x squared, which is x to the 4th. And then we have subtraction. And x squared times 3z to the negative 2 power y. So we'd have 3 x squared z to the negative 2 power y. And for the denominators, we have y to the negative 3rd power times y. And when we're multiplying, remember that we're doing negative 3 plus 1, because 1 is the exponent for y. So you add the exponents, which actually equals y to the negative 2 power, because negative 3 plus 1 is negative 2. So it'd be y to the negative 2 power. And then distributing it over here, it's y to the negative 3rd power x. Okay, now what we can do is rearrange our negatives and get rid of them by moving them to the opposite side of the fraction. So if this y squared is going to move to the top, this z to the negative 2 power is going to move to the bottom, and this y to the negative 3 power is going to move to the top. So we'll rewrite our equation. X to the 4th is going to stay the same over there, but now there's going to be a y squared on the top as well, which leaves nothing on the bottom, so it's just over 1, which we can just leave that off. And then over here, we're going to have 3x squared is staying the same because it's not circled. But the z squared is going to move to the bottom. And we still have a y up here, but we're also moving up the y to the 3rd power. And then on the bottom, we have the x that is staying the same. So now we can see that we have multiple y's up here that we need to combine. So that will become y to the 4th power. Now we need to take a look and see if there's anything that needs to be canceled. So we have x squared here and an x here. So this x will cancel out one of the x's on the top and just make it x to the 1 power, which is just x. So now we need to rewrite this for our answer. So we have x to the 4th, y to the 2nd power is staying the same, minus 3 stays the same. Our x just became 1x. Our y became y to the 4th. And on the bottom we have z squared. And the x was canceled out. Then we need to list our excluded values, so we need to look at anything in the denominators. So we have a z, we have an x, and then looking back at the original, we also have y's in the denominator. So z, x, and y cannot be 0. And that's our, oops, I cut off my 4. That's our final answer for that one. Moving on to the next example. The more practice, the better with these problems. Okay, we're going to distribute again. We have a to the negative 1 power. So that there's no other a's to combine it with, so that will stay a to the negative 1, and then 3, b, and m. Which technically that 3 should be first, but we can change that later. Plus a to the negative 1 times a to the negative 3. So we need to do negative 1 plus negative 3, which will be a to the negative 4 power, and then c to the negative 4 power. And for our denominators here, we have b squared times d, a to the negative 2nd, c to the negative 4th. So this is a lot of exponents and variables to keep track of, so you need to go carefully. There are no other b's to combine with on that one, so b squared d, a to the negative second power, c to the negative fourth power. It is really important to show your steps on these problems because it's very easy to get all of these exponents confused. So the next term doesn't have a denominator, so it's just over 1. So it'll be b squared times 1, which is just b squared. Okay, so our next step is to move our negative exponents. So we have one here, we have a to the negative second, c to the negative fourth, a to the negative fourth, c to the negative fourth. So those are the ones we need to flip. So we have on the top, 3bm is staying the same. Maybe I should highlight that in yellow. And on the bottom, b squared is staying the same. Now we need to move the ones we highlighted in pink. So a to the first will go on the bottom. Oh, I missed a d as well. Down here was hiding behind the pink. Okay, so we have a on the bottom, and then we're also moving an a squared to the top and a c to the fourth to the top. So this is what we're left with right now in that term. And then on the other side, we're moving both the a and the c variable. So what's left up there is just going to be 1. So we'll have a to the fourth, b to the second, c to the fourth on the bottom. Now we can go back and look and see what we can cancel. So we have b's on the top and the bottom here, and we have a's on the top and the bottom here. And then the m, the c, and the d don't have anything in common. And then the other one, the second term, doesn't have anything to cancel. So we have 3 that's staying the same, we have m that's staying the same, and we have c to the fourth that's staying the same on the top, and then we have a d that's staying the same on the bottom. Now, we're looking at our b's. This 1b is going to cancel out one of these b's and just leave 1 on the bottom. And then this 1a is going to cancel out one of these a's. So that will leave an a on the top. So we have 3m c to the fourth a on the top and db on the bottom. Now you could rewrite those in alphabetical order, but it's not super important. And then the next term is 1 over a to the fourth, b to the second, c to the fourth. Now for our excluded values, we have d and b can't be 0, and a and c also can't be 0. Looking back at the original equation, there aren't any additional values that can't be 0, so it's just these 4 cannot be 0. And that's our final answer for that problem. Okay, we're going to have to pause and restart again so that we don't go over 15 minutes. So this will be the end of part 1. Please restart with part 2.